Okay, so hello, I am putting this video together just so that we can still kind of keep on pace with the class. I apologize if I sneeze and or cough during it. I will try my best. I may have a few cuts here and there to take little breaks, but we are going to finish up today rational expressions. So we've added these things are the ones that have the fractions that are a polynomial over a polynomial. So we have things like 2 over x plus 3 over x plus 1. And so we set about the way that we would solve that is we first had to find the common denominator. So we said in this case we were going to make it super simple and just take each of the pieces and put them together as one denominator. So I'm going to write that below. X times x plus 1. Put that over like that. X times x plus 1. And so now I've got my common denominator. And so I need to adjust the tops with that denominator. So in this case, for the first term right here, I've got, what did I multiply x by to get my common denominator? Well, I multiplied it by x plus 1, right? So I'm going to have x plus 1 times 2. Over in this one, what did I multiply the second denominator by to get the common denominator? So that is plain old x. That's the difference between that denominator and this denominator. So I'm going to multiply the top by x. So here we go. I have it all set up now. Next step is to distribute. So I'm going to have x. Let me actually put this x plus 1. This is one of the things I don't like about adding and subtracting common denominators, or not common denominators, but rational expressions, is that it's a lot of writing. So here we go. 2 times x is 2x. 2 times 1 is 2. Okay, so we have now distributed the top and we're ready to add with that one. And now I've got over on the second term, x times 3 gives me 3x, and this was added together. Alrighty. Now, since we have the common denominators, we can add straight across, top to top. So let me put the common denominator back under x times x plus 1. And then it's going to be 2x plus 2 plus 3x. So 2x plus 3x, 5x, and then plus 2 is what's left. And so this gives us our answer right there. That's how you add these rational expressions. Next, let's look at actually subtracting them. Okay, so let's do another example, a little more complicated. Let's try x over x plus 3 minus 2 over x minus 1. Alright, let's build the common denominator first. So x plus 3, x minus 1. Just multiplying them together. X plus 3, x minus 1. Okay, now I have to adjust the top. So what did I multiply the original denominator by here to get the common one? Well, I multiplied that by x minus 1. So I multiply x minus 1 times my top. Now what did I multiply this denominator by, the second one, to get the common one? Well, I multiplied by x plus 3. So I have to multiply the top by x plus 3. Alrighty? So now that I have everything set up, all I have to do is distribute the top. So I'm going to wind up, hold on, let me write this down. X plus 3, x minus 1, and x plus 3, x minus 1. Okay. So now that I have that, I can distribute x times x. It's going to give me x squared. X times 1 minus x, so negative 1. So that's going to be a minus x. Now I'll come over to the next one. So I've got 2 times x, 2x, 2 times 3, 6. Okay. Now I can subtract the tops. So I know my denominator is always going to be x plus 3, x minus 1. So now let's work on the tops. Well, I only have one x squared term, so that's going to be up here, x squared. And then I've got negative x minus 2x, which is going to give me a minus 3x. And then no numbers except for the 6. But remember, this is a minus sign in front here, and that applies to the whole thing. So minus 6. And that is our answer for a slightly more complicated one. Alrighty. So we'll start again with a more complicated one, and this next one will be about as complicated as you would see on an exam. Okay, so here we go. Let's give a more complicated example. Let's go with something like x plus 2 over x minus 3 minus 7x over x plus 1. Alrighty. So our common denominator is going to be the two denominators. So it's going to be x minus 3 times x plus 1, like that. And so it's going to, for both of them, x minus 3, x plus 1. Alrighty. So now, what did I multiply the original first denominator by? Common one? Well, that was x plus 1, so I multiply by x plus 1. So x plus 1 times the original top, x plus 2. And over on this side, what did I multiply the denominator by? The common one, I'd multiply by x minus 3. So x minus 3 times 7x. Alright, so here we go. I now need to adjust all of the tops, but before I do that, I'm going to copy all down my denominators here. So I've got that one, and then this one. Alrighty. And so, let's see. Let's distribute. Yeah, we're not foiling, we're distributing. So I'm going to do x times x, x squared, x times 2, 2x. Okay. The x has been distributed. Now I distribute the 1. 1 times x, x, 1 times 2, 2. Okay? And I'll come over here. X times 7x, 7x squared. Negative 3 times 7x, negative 21x. Okay? Now I can combine my tops. Let me put my x minus 3, x plus 1 denominator down. And now let's add across, or subtract, I guess would be a better way to say that. So I've got an x squared here, and a minus 7x squared here. So x squared minus 7x squared will give me negative 6x squared. I've got 2x plus x, which is 3x, minus negative 21x. So it's going to become a plus 21x. So 3x plus 21x is plus 24x. And then finally, plus 2. And that is it. That is as complicated as you might see. Alright, so next let's move into multiplying and dividing these things. Okay, so let's do some multiplying and dividing rational expressions. So let's start with something like x squared plus 3x plus 2 over x squared minus 9. And then times, let's do x squared minus 5x plus 6. And then over, let's try x squared minus 4. And we'll see how this goes. Alrighty, so I've got, before I can do anything, I need to factor each one of the tops and bottoms so that I can see which things I can cancel. So let's start by factoring this one. So I'm going to have two sets of parentheses. I've got an x and an x. And this back sign says that the two numbers are either both positive or both negative. The middle sign says they're both positive, so plus, plus. What are the two factors of 2 that add to give me 3? Well, that's just 2 and 1. So 2 and 1. And then over, well, I've got right here, x and an x, and then this back sign is a negative. So I'm going to be looking to subtract the factors, and also I think I'm going to have plus minus. I should say that first. Now, what are the factors of 9 that subtract to give me a 0x? That's what's hiding out up in here. 0x is in there, but it's just, we don't see it because it's a 0. So I know that when I subtract, I have to wind up with a 0. So what two factors multiply to give me 9, subtract to give me 0? Well, those are 3 and 3. Alrighty. So now, over here, I'm going to have two sets of parentheses again, x and an x. Alrighty. Now, this back sign is positive, so that means either they're both positive or they're both negative. This sign right here says they're both negative, so minus, minus. And what are the factors that multiply to give me 6, but add to give me 5? 2 and 3. Okay? Now, the bottom one, last but not least, we've got an x and an x. This sign is negative, so it's going to be plus minus. And there's a 0x missing it from in here. So what are the numbers that multiply to give me 4, but subtract to give me 0? Well, that's just 2 and 2, right? All right, here we go. Let's start canceling. So I've got plus 2, no plus 1, x minus 2, there it is, right there. And then x minus 3, well, that leaves me with x plus 1 over x plus 3. All right, so not too bad. The main thing is you just have to be able to factor all of this. And once you get all the factors, since it's a multiplication here, I just start canceling anything that is over itself. In other words, an x plus 2 on top, x plus 2 on the bottom, they cancel. X minus 2 on top, x minus 2 on the bottom, cancel. X minus 3, cancel. The only thing that's left is x plus 1 times x plus 3. And I should also note that it doesn't matter which set of fractions that these factors are on. You know, I've got the x minus 3 here, and I've got the x minus 3 over here on this other one. The other term, not term, yeah, I guess the other rational expression, we'll say that. But it doesn't matter because I could rewrite this. Oh boy, here we go. Since it's multiplication, I could have rewritten it as like this. And no, it would be kind of a lot of work to do, but this is what the reason why I can cancel is because when you're multiplying fractions, you multiply straight across. So really, this expression right here is the same as this because this multiplying is kind of like hiding right in there. And so now it explains why I'm able to do this and get away with it, why this is legal. Alrighty? Okay, so that is multiplying. Now let's do one with dividing. Okay, so we're now going to be dividing rational expressions, but before we do that, let's take a quick review on dividing fractions in general. Let's say that I had, and these aren't going to be simplified, they're just here to kind of show what's going on. 6 over 15 divided by, 9 over 20. Alrighty? So, when I am dividing fractions, this could also be written as 6, 15 over 9 over 20, like that. Whichever one you prefer. This is the form that you'll typically see these in just because it's a lot easier. Although sometimes you might have a complex fraction like that. But the main thing is dividing fractions is exactly the same difficulty as multiplying because to divide fractions, all we do is we take the second fraction, this one right here, and we flip it and change the division into a multiplication. Just like that. So now I've got it rewritten as a multiplication. I'm going to factor each of these pieces into their prime numbers. So 6 would be 2 times 3 over 15. 3 times 5 times 20. It's going to be a little more complicated. It's 2 times 2 times 5, and we could have gotten that with a factor tree. And then 9 is going to be 3 times 3. Alrighty, as before, we're now going to cancel. So 3 and a 3, gone. 5 and a 5, gone. And I believe that's everything. So what is left? 2 times 2 times 2, 8. 3 times 3, 9. 8 nines. So that's how you do just standard fractions. Now let's do some rational expressions. Alrighty, so let's start off with maybe x squared minus 1 over, let's go with x squared plus 7x plus 10 divided by, let's see, x minus squared 3x minus 2 over x squared plus 6x plus 5. Okay? First thing I do before I do any of this is I change this division into a multiplication by flipping the second fraction. Okay, so I'm going to recopy x squared minus 1 over x squared plus 7x plus 10 times, now I'm going to flip it, so the bottom becomes the top, x squared plus 6x plus 5, and then x squared minus 3x minus 2. Okay, now I'm going to factor the top one. Well, I've got an x and an x, one of the two factors that multiply to give me, what's plus or minus, let me do that first. That multiply to give me 1, but subtract to give me 0, well, that's just 1 and 1, right? Okay, move on to the next one. Here we go. An x and an x. And then this back sign says the two signs are either plus plus or minus minus. This sign says they're plus plus, so plus plus. What are the two numbers that multiply to give me 10 but add to give me 7? Well, that's going to give me 5 and 2. Alrighty. Now let's move on to the next one. Got my x and an x. And then two signs are either positive positive or negative negative. That says they're positive positive. Okay. So I'm going to have what two numbers multiply to give me 5 but add to give me 6? That is 5 and 1. Alright, last but not least, here we go. Oh yeah, and that one should be a plus sign right there. Sorry about that. That should be a plus sign. I almost messed this completely up. So here we go. I didn't notice until I was about to factor. So I've got an x and an x. And then I've got what two numbers? Well, there's a plus here. Let me clear my thoughts. There's a plus sign here. That means that either the two numbers, the signs are plus plus or minus minus. This says they're minus minus. So minus minus. What two numbers multiply to give me 2 but add to give me 3? Well, that's just 2 and 1. Alrighty. Now that we have done all this work, we can start canceling things. Is there an x plus 1 down here? No. What about an x minus 1? Yes. Okay, move on to x plus 5. Yes. And that's it. So my answer is going to be x plus 1 times x plus 1 over x plus 2, x minus 2. Alrighty. That's it. Leave it just like this. Don't do anything else. So dividing rational expressions is exactly the same as multiplying. You just have to remember to swap the top and the bottom, flip them. When you are going to change the division into a multiplication, you always swap the top and the bottom of the second fraction. Once you do that, you factor everything out, cancel what's in common, and whatever you're left with is what you're left with. Alrighty, this concludes our lesson for the day. I will give you a little bit of homework real quick. If you will, knock out the following. We'll go over it on Monday. This will not be for a grade, but it is something I'd like y'all to practice if you get a chance. So let me clear this up. Try the following on for size. Let's go with x squared minus 9 over x plus 9x plus 14 divided by, get the little dots. Let's go with x, my x squared minus 4x plus 3 over, let's see, let's go with x squared plus, let's try 8x plus 7. Let's do that one. I think this one will work out nicely. Not perfectly, but not too bad. Alrighty. I think that is just about it. So try this one on for size. We'll go over it on Monday. And y'all have a great weekend, and I will see you then. Bye-bye.